So I'm Troy Wojewoda from Newman Shipbuilding, and my talk today is going to be Bros Before Flows. And it's really a talk about network data acquisition in regards to incident response. So real quick, a little bit about myself. Kind of been in the InfoSec and IT realm for about a little bit over 10 years. Started off as an intrusion detection analyst, kind of network and wireless, and then kind of moved on, did a little sysadmin kind of stuff, various system application admin deals. But then, as I kind of evolved through my career, started getting a little bit more into incident response. Today, now I actually lead the incident response team at my current employment, and also focused on IOC hunting, campaign analysis, a little bit of malware analysis, kind of like multiple hats kind of thing, but mostly, and also the endpoint and network forensics. But when I'm not kind of cybering the things, I do enjoy being in the outdoors. I love the mountains. I love camping and hiking, and Virginia is a beautiful state to be able to do that in. And I do enjoy home brewing, but I mostly spend that time home drinking, especially after having 3 kids. I really have the time to get into that, but definitely a craft and a hobby I enjoy a lot. So just real quick, just to level set things, what this talk is not about. It's not about defacing or bashing NetFlow at all. NetFlow is a really powerful tool. But also just to kind of show from an incident response perspective, you're going to hear me over and over again today talk about context, context, context. And context is our friend, and time is our enemy, especially when dealing with network data acquisition. And then over time, as that data is going to, as we go from the full picture, a full packet capture, down to like rudimentary stuff, time is going to be crucial in being able to grab that data and be able to have it to combat that incident response. Also, this is meant to be vendor agnostic, and mileage may vary for everybody. One size does not fit all. So what I talk about is hopefully a generalistic approach at data network acquisition, and it may not necessarily apply to you or your networks, but hopefully you can bring some of this back with you to secure your corporate networks. And also, the opinions here are that of mine and not of my employer. Just kind of have to throw that one up there real quick. All right, so real quick, I said the highlight of this is really to show how do we do incident response with data network acquisition. So we have, I'm showing the famous pick-a-roll phases of your IR, highlighting identification here because this is really the key. And I actually like to show the Lockheed Martin's cyber kill chain. And although that paper hits on more than just dealing with things in incident response, it's campaign tracking, adversary tracking, and whatnot. What I like to highlight out of that, from that kill chain, I kind of visualize, and I try to help show this to my team as well, that there's certain things in that phases of the kill chain, such as delivery, exploitation, installation, and command and control, and how those areas that essentially what the attacker has to do to be successful against you, how are you detecting things evil on your network as it applies to those different phases. And I highly suggest that if you're on a team that you're writing rules, you have these rules that are written to detect things, that you're tagging them or categorizing these rules somewhat based off of the cyber kill chain phases. For a case in point, you might have a rule, an IDS rule that looks for a certain URI pattern, but that URI pattern is specifically written to detect the delivery phase of an attack. But at face value, maybe to an entry-level analyst or somebody else looking at that signature, they might not know that that attack is written for delivery phase. It might be written for, or they might think it's command and control because it's over the network, so it has to be command and control. So being able to differentiate and categorize your rules is highly important, especially to help those junior level analysts when a rule does fire. I know we've probably been doing incident response long enough. You've seen other rules that have fired that you didn't write, and you're trying to understand what that rule is written for. Having that categorization of where it falls is highly important. And it's also important for escalating that incident as well. So if something fires in the delivery phase in the kill chain and you stop the attack, it's probably less likely that you have to escalate it to whereas you get a detection on command and control. because then there was some other action that happened on the network that you did not catch, and you have to go back and find that. So I like to kind of caveat that and show where there's a crossroads there, at least in my eyes. And kind of going through these phases as a member of the IR team, hopefully you have more than one person on your IR team. And as you're going through, one or more members are going forward, trying to go through these phases. You maybe have a member or two that are backwards pedaling, looking back, have I fully identified the scope? Have I fully identified everything? Is there something I'm missing? So you're constantly revisiting this identification phase. And then same thing for eradication and recovery. And I know we all have been there, especially if you've been doing incident response long enough. You've had that incident where system was beaconing, quickly taken off the network, hard drive slicked and reloaded, right? So there was no look into how that system got comped. Were there other systems comped? It was just quick, slick reload, wipe our hands, and move on. And that's a symptom I like to call premature eradication. And so if you can at all costs avoid premature eradication for your IR team and your IR process, that's definitely a good thing to do. All right, so kind of going through now the core point of this presentation is the data network acquisition from, and I call this kind of like the stack, if you will. We're going to go from the most contextual-based resource, which is our full packet capture, and kind of go down the stack. And I'm going to talk about things like, obviously, full packet capture, the Bro IDS, a little bit on application proxy and gateway logs, IPFix or NetFlow, your traditional IDS and IPSs, and then down to the firewall. So just real generalistic network here. We have our DMZ, maybe hosting a web server that's internet exposed to allow inbound 80, 443, what have you. Maybe an MTA mail server, and then say a file share, whatnot. And then inside your network, maybe you have some segmentation. Hopefully you have a little bit of segmentation between your clients and maybe your server-based infrastructure. So what do you do? Where do you get started? So essentially you want to identify your critical choke points. The less choke points you have, the better, the easier this will be. The more, obviously, the more complex things get. But if you can find and identify those choke points, then you're going to be able to obviously key in on what data is leaving or coming into your network. So you probably want to start with your full packet capture at those critical choke points. And maybe you want to run Bro in parallel to that. And then maybe Bro, in between comms from your segmentation internally on your network. And then there's NetFlow. So NetFlow is something that if you have a corporate environment and you're running any kind of corporate level layer 3 switches and routers, you probably already have this technology and you're paying for it, so why not use it? This technology scales really well across your network. And like I said, you're probably already paying for it, so why not use it, right? And then your traditional IDS, maybe you want to run that in parallel with some of those critical choke points as well. And then really from an incident response perspective, you want as much centralized logging as possible. So if you're battling an incident and you have to log into 15 different systems to get all your data, that's time that could be spent doing other things, trying to find the evil, the badness. And so the more centralized things are, the easier it's find. The more things are coming in, the easier it is to kind of combat that incident. So whether it is one of these technologies that I mentioned, or it's other firewall logs or other logs or endpoint logs, the more centralization that you can get for this data, the better app that your team's going to have at being able to combat that. So we'll dive into full packet capture. So what is full packet capture? It's basically see everything, know everything that goes over the wire. There are some caveats. Encryption, obfuscation techniques are going to throw us for some loops. There are some little caveats with that too. I'll get more into that later on. But essentially, everything that traversed that wire, you see it all. If you want to get started with full packet capture, there's a really good friend of mine who wrote a paper. May or may not be at this conference today, but it's really good. Roll your own kind of full packet capture using TCP dump and some. Basically, you just get your own hardware and just go. Then there's also, Google has a steganographer. I don't know if anybody heard of this. I recently learned about it. It's basically written to spool data quickly off the wire and onto disk. It's not made to go through and do analytics on the PCAPs. It doesn't do stream reassembly or anything like that. But it's just made to do one thing and do it really well, is grab data, spool it to disk really fast. And they're talking about like 10 gig type connections and stuff. So really cool stuff. And then in the commercial marketplace, there's obviously some folks that are doing it and doing it well. I also just learned of Splunk app for Stream. That was kind of neat, kind of looking at how folks are doing things in a little bit more of the virtualization or cloud environment. So there's definitely some wins that could be had there if you can't go with one of these other resources. All right, now Bro. Who here has heard of Bro? That's awesome. That's awesome. That actually makes me really happy. So Bro is something I've been using since about 2013. I don't know if anybody knew this, but Bro is over 20 years old. That's kind of surprising. But it's definitely, it's labeled as an intrusion detection system, but it's much more. I look at it as like network forensics. I look at it as if you want to do DLP with it, you can do that. If you want to do intrusion detection, it's there. It's just network logging of all the things and metadating all this stuff. And it just surprised me all the time when I'm looking at that, especially dealing with, when I first started doing intrusion detection, basically having an alert fire and you have one packet of the result of what that signature fired on. And then you're trying to understand what the heck is around that. You don't even have full packet capture. But even if you do have full packet capture, going through all that data can be time consuming. Bro just if it understands that application protocol, it writes a log to it. It's fantastic. And we'll get more into Bro, obviously, as the presentation goes on. I was debating on whether I was going to talk a little bit about proxies and gateways. It's not something that scales across your network like I mentioned earlier in that slide where I was showing where your critical choke points are or not, but it's definitely a value-add resource to have from an incident responder's perspective, because it's for that particular application or proxy that it's serving up for, that the data that's going to be in there is going to be really, really contextually rich. All right, so you're going to have, say we're talking about an HTTP proxy, you're going to have authentication users in there, maybe hosts in there that are authenticating. You can do categorization, whether or not that the websites are categorized. Obviously, with email, you have anti-spam capabilities. With both of the technologies, you can do AV scanning. Things are going more, also for the inline protection, they're really, really good there, but they don't scale very well across, right? So they're made, this one does SMTP, this one does FTP, or this does HTTP. They're really good for those protocols, and obviously if you have those resources on your network, you should be getting those logs to help you understand the incident as it's existing on your network. So IPFix, or otherwise known as NetFlow version 9, essentially, like I mentioned, if you have any layer 3 switches or routers on your network, you probably already have this capability, this technology. Essentially, it's a two-state system. There's exporters and collectors. So all your layer 3 switches and routers are your exporters. You're exporting out the flows. And then your collectors are those things that are the servers that are collecting that flow data. And it's a bidirectional thing. So you can actually, you get a record for, say, the traditional client-server communication. You have a flow from client to server, and then another flow record from server to client. And you can kind of understand how data is moving around in your network. And so you can baseline things like these clients are generally surfing the web, so there's very little flow going outbound and a lot of flow coming inbound because they're doing tiny little GET requests and bringing down payload. So you kind of understand that picture on your network. A lot of things that are involved, especially in version 9. Essentially, it boils down to, in my mind anyways, source and destination IP addresses, source and destination ports, the amount of data that flowed. You get much more though. You've got the autonomous system stuff that you can put in. You can look at. You can look at layer 3 routing. That stuff is being collected. There's a lot going on. So, and then our traditional IDS and IPS systems. Traditionally written to basically look for a certain pattern or signature. Usually this technology is not something that's going to be doing a lot of logging. It's going to be alerting or logging based off of what it knows about. So aside from the other technologies that are basically just collecting all the things, this is going to be like, I'm going to log or alert you on something that you tell me about going forward, nothing really looking back. There are, obviously open source solutions like Snort and Suricata. I mentioned Bro in here because it's labeled as an IDS and can be used as an IDS. Security Onion and Rock NSM, they're more than just IDSs. They're like compilations of IDS technology, full packet capture, logging, elk stack, those kinds of things. There's a lot of things going on. But I just kind of threw it into this slide as a general intrusion detection or prevention type space. And I'm not really going to get into the commercial space here, but the pattern, or at least with where technology is going with future IDSs, if you will, are more not just statically based, but that behavioral stuff. So pulling stuff off the wire, running it in VMs, those kinds of things. I kind of categorize that as intrusion detection systems. And then firewalls. Not going to go too far into this, and this can go off. We could talk all day about what's the difference between all these different types of firewalls. They're going to range across all different, depending on your environment and what kind of firewalls you use. And obviously, the next generation firewalls have everything. Maybe not. But essentially, from this perspective, what we're going to look at here, we really want to know what were the IP addresses that either flowed through or were stopped by the firewall, and maybe and obviously the ports, the protocols, and the ultimate question: was it allowed or was it not allowed? And so what I'd like to do is actually walk through a real attack. So this is actually an example of something that I was looking at just, I think, the second week in May. So this is kind of fresh ransomware stuff, or at least a couple weeks old ransomware example. And so the example is a malicious email comes in, Word doc, macro-enabled stuff, and then afterwards some DNS requests, and then you see some GET requests, and then some other type beaconing information. So we're going to actually look at what that means from a full packet capture solution. So if you have full packet capture, we're looking at the email. Now I'm trying to protect some of the innocent here. But essentially, this is what a SMTP message looks like raw. If you ever looked at it off the wire, there's some other information that goes on between two MTAs. They're going to do their send, ACK. They're going to set up their TCP connection. They're going to do some SMTP negotiation. And then one's going to say, I want to send some data. And then the receiver is going to say, OK, send it. And this is the data that comes. So a lot of people look at an email and try to dissect it and say headers and bodies and bodies and headers. But really, a raw email is everything. It's the headers and body. There's no difference in a raw message. And it's really text-based. It's always was originally meant to be text-based. But I'm splitting the view up here to show the headers and the body. But we could see everything. We could see all the received hops. We can see all the information there, all the servers that bounced around, the X mailer. That might be some information that we could use later on. And then we can see that there was the attachment name and then the base64 encoding. If you're not familiar with some of the encoding techniques, base64 is one of the more popular encoding techniques to encode stuff that's not plain text over SMTP. And so that you see all that. You have the attachment. You can pull that out. You can do whatever you want with it. And then moving on, we see that the client got this email and clicked on it. And then we see that there was a GET request to www.oracle.com. And then we kind of paste together, or try to put together the client request with the client the response. And we see that a valid IP address comes back down. And then we see the same thing for a somewhat new-looking domain, Pompeii-distribution.com, with another IP address. And then shortly following this activity, we see there was also an HTTP GET request to the www.oracle.com site as well. Not showing it here, but what we do see is directly following off a successful GET request to the oracle.com site, we see a request for some h.jpg, and we obviously see a valid JPEG come down, right? So not really. It turns out that this is an XOR encoded Windows executable. But we can see that now with full packet capture. We follow the streams, we look, we see, oh yeah, this is interesting. You're definitely not a JPEG, so we can pull that off, go through our decoder techniques, and then say we have a Windows executable that was downloaded. And then shortly following that, we see this beaconing to over UDP to 85.93. It's a /18, which was some kind of interesting information. There's a little bit of information in the payload of the UDP packet, beaconing information. But we see all, we know all. We have the full capture of the entire incident, if you will, with full packet capture. So now we move on to Bro. So we take the same attack, and then we look at what did Bro see. So Bro, as I mentioned, is very application-rich, protocol-aware. It's going to, if it knows about that application or protocol, it's going to write a log. And in this case, it sees a bunch of things that happens. It saw some HTTP traffic, so there's going to be a log for that. They saw some DNS and some SMTP traffic, so there's going to be a log for that. The con log is actually a log that Bro creates based off of any connection that it sees. And there's going to be a record there. And then, as we're going to see going forward, it creates a unique identifier, and you can track that unique identifier exists throughout the other logs. If that connection had SMTP or FTP or whatever it had, you can track it all through. So they separate the logs so you can get that granularity across that metadata, if you will. And then that connection log is kind of like the route where you go to then say, where do I need to break off to? And then there's the files log that we're going to look at as well. So excuse the verbosity of the logging. I actually trimmed some of this down, but anybody that uses Bro or looks at Bro knows that it's extremely verbose. Their logging is, there's a lot going on. But essentially, what we have here is the SMTP log of the data that message that I showed you earlier in full packet capture. We have that unique connection ID that I mentioned. You can see the sender and IPs, and I X those out. But there's a couple email addresses that is actually recording, which is interesting. The first email address is that SMTP mail from address. From Zach and Andrew's presentation earlier, you saw that how they spoofed the email, and they went from, there was a mail from, and then there was also a from in what was considered the 822 message header from. And so Bro sees those both, and they logs them both. So you can actually look there. The message ID is being saved. The subject, which is that Chester Blanchard, that's the subject. What's really cool is Bro's seeing all those upstream IPs, and it's actually logging them comma delimited. So those are all those IP addresses you see. It sees the X mailer, it's logging that. And then there's these F-looking unique identifiers that are like the connection ID, but the F IDs are actually unique identifiers, but particularly to files. So if Bro sees a file over the wire, it's gonna log that in the files log, and then you can actually pivot into and pivot around to say, show me more about that particular file. Now, the reason why we see two file IDs there is because in the SMTP message that we saw, the attachment was one MIME type, or one attachment, if you will, and the second file was actually the body, the hello, please open this kind of thing. That's a text file, and to the SMTP protocol and to Bro, that's another file type. It's just a text file. So we don't really care about the first one, but we do care about the second one. In this case, Bro also does magic. Not so much magic, but it actually is looking into the file, the magic of the file, and is matching that up with a library that it has. And so it doesn't really matter what you name the file extension. If it's a .exe, it's going to log it as the magic of an exe. In this case, it logs it as a Word document in the correct format, the new XML-based Word format. And because I'm using and then there's the attachment name, and because I'm using the file analyzer and attaching that file as analyzer, and that's a framework I'll discuss in a little bit, I'd say when you see a file, go ahead and give me the MD5 and SHA-1 of that file as well. So that's actually those two values that are going there. So we lose a tiny bit of context. We don't have the raw actual attachment, but we have a lot of information about that attachment. So then moving on, the DNS. DNS is kind of interesting because Bro attacks UDP traffic in a very unique way, some way I never really saw before until I started looking at Bro. Because UDP is a stateless protocol, Bro tries to look for those responses, and if it sees a response, puts that entire message on one line. So in a sense, Bro is actually adding somewhat of a state to a stateless protocol. So it's kind of interesting and neat. In this case, it saw the request for www.oraclecode.com. It said, here's your answers that come back. You see the comma delimited answers, and then you actually see the TTLs that come back with that answer. Now, there's more information I took out of this. There is a record type, and you would see it would be a forward A lookup, and there's a couple other things that could be, but I wanted to kind of keep it as slim as possible. And then we see the pompeii.distribution.com. But now, because this UDP traffic is a different connection than what's going to follow with HTTP, we can see, okay, here's what the answers that came back. Now let's look in the con log to see, did we see anything to these two IP addresses? And sure enough, we have communication to the two IP addresses. And then pivoting off the connection ID now that we found in the con log, we can then go into an extremely verbose log source, and that's the HTTP log. Now, Bro is not logging everything it sees over HTTP. There's so much that goes on, but it's trying to capture as much as it can. So we see the source and destination IPs. We see the host name. We see the user agent. We see the actual response, HTTP response. So first it was a 301 move, then it was a 206 partial content, and then again for another. But then as we look in here, and we have that files ID, we see that it was recorded over HTTP, but when it tried to do that magic analysis on the file, it tried to look at see what file type that was, it came up empty. So in this case, in that case, we actually start to lose more context. We lost a little bit more. So Bro saw that traffic, and unfortunately, it saw a file. Now, we did have the file size. If you want to go back real quick, we could see there was 411K of a file that was downloaded, but we just don't know what type of file that was. And then finally, this UDP beaconing. Essentially, it was a /18. It created 32,000 packets because even though there's only 16,000 something blocks in a /18, it did this twice. So I think the first time it started off over port 6892, and then it went to, or 6891, and then the second efforts were started off with port 6892. What was interesting though is I kind of, I trimmed this con log down a lot, but I wanted to show this S0 flag. Does anybody know what that S0 actually is indicating in Bro? Anybody? It's actually saying that it saw a UDP packet out, but it didn't see a response back. So it's kind of cool, like going back to that adding state to a stateless protocol. It's a neat concept. So we saw this over SMTP, where we got a lot of information over SMTP. We pretty much lost nothing other than the raw attachment, but we got the hashes, we got the name, the size, we got pretty much everything in the header. There's a little bit stuff that we missed in the header, but for the most part, we got a lot of rich information that we can use as indicators going back in the header. The DNS, we have everything. We lost nothing in DNS, essentially. And then we lost a little bit as we started going down HTTP. And then in the con log, we got everything, but we just don't have the payload that was sent in that beaconing information. So moving on and kind of looking at what flow data would show you in this incident and showing how much context that we start to lose. So essentially, because we lose all this context, a lot of this stuff is going to start to blend in with your corporate network. Now, you might be, because you have those publicly adjustable IP addresses, you might be able to key off of those things in all these different types of log sources. DNS is going to be harder to do unless you're actually, from a flow perspective and in a firewall perspective, DNS is going to be just regular DNS traffic. Unless we're talking about DNS tunneling, nothing's really going to stick out here with just general forward lookups that then end up being HTTP for GET requests or whatnot. That traffic is all going to just blend in with your corporate data. So just a real quick, and I know this is probably tough to see, but essentially that's the information we have on the SMTP. So we have one flow record from the receiver, from the receiving MTA, from the sending MTA, and then one from the sending MTA to the receiving MTA, and you can see that the amount of bytes was much higher coming from the sending mail server to the receiving mail server, but essentially that's all we have. Our DNS traffic is going to just blend right in. And then HTTP, essentially, the only thing you're going to have is those public IP addresses. You're just going to see, yes, it went out to port 80. And this is how many bytes flowed. And then there's your beaconing information. Now, the beaconing information might be something that you could detect with flow, because you're going to see these beacons, and also port over port 6892. As well as in your firewall log. So here's the kind of snippet of what firewall. So instead of having two flow records, now we just have one entry that, yes, we allowed SMTP inbound over port 25. That's nice to know. And then, yes, we allow DNS. And yes, we allow that HTTP connection to that IP address. But that beaconing information, obviously this firewall was configured to allow outbound 6892, but that we have all that information, but we lost all that context around that incident. So for the second scenario, I wasn't going to go deep dive in an actual incident. By the way, does anybody know what particular ransomware family that was? No? It was Cerber, so the Cerber stuff. It's kind of been the latest round. But essentially what I did was I wanted to take a sample size over an hour, say, and again, depending on how big your network is, this might be a small sample size, or it might be a large sample size. But I wanted to take, so you have an hour worth of PCAP, and then you're as an incident responder, you're told something suspicious happened in this hour, so find it. So you have 150 gigs of PCAP. That kind of, going through my sample set anyways, came down to when I run those PCAPs through Bro, gives me about 48 gigs. But we see those two data sources are exponentially greater than just dealing with flows and our firewall logs. And fortunately for us, those two big data sources do compress pretty well. I just use gzip to compress them, and we see we have a 6 times efficiency rate if we compress our full PCAP, almost 7 for Bro, and then as we go down that stack, that stuff compresses really well. We can keep that stuff a really long time. So, and not to kind of go into the pyramid of pain from some of the other examples that were shown, but this is my own pyramid of pain as far as dealing with lots of data and being able to search that data. So we want context. Context is our friend. But as we go down the stack and we try to grab that context, we obviously see that the searching is painful. And then if we flip that pyramid over, we could see that time is not our friend unless you have unlimited disk space. As we go down in time, we start to lose our data. So all that context-rich data is going to have to then start to roll. And so with that said, time being, if you come into an incident 30 days after you've been told about it, you may not necessarily have the full PCAP. Hopefully you'll be able to have something like Bro that can give you that, some information back. And this is just a quick little matrix that I put together. Really everything in green is a pro for that technology. Everything in red, the negative. And then I kind of put some maybes out there depending on, is Bro easily searchable? Yeah, it's easily searchable in my case. It's easily searchable maybe in a week or two. But if you don't have something like Splunk or using something like Elasticsearch or something like that that's going to help you, or maybe you write your own custom indexers, sometime that data is going to then start to grow, especially with your HTTP logs, your con logs, and your DNS logs, stuff that traffic is just going crazy on your network. Those logs are going to get really big, and it's going to be hard to search over time. So I'll leave that one as a maybe because there's something you can do to help yourselves with. But essentially, we're looking for going down these columns. Application specific is a negative here. So we want something that will scale across multiple applications, multiple protocols that we could put at those critical choke points, and it does all these things. So obviously that's a negative for those specific proxies or those application proxies specifically. And then we want the context. We want that rich context. We lose a lot of that with flows and with firewalls. Look back capability. Again, as I mentioned with the traditional IDSs, you have a signature that you put in, and it's only really efficient for going forward. You don't really have that capability to go back. And so that's really critical in a lot of cases because I don't think most incident response teams can afford to not be able to look back. You've got to be able to look back. Things are going to come out, and then you need to be able to, I think there was mentioned earlier that hashes are very little value, and I agree with that moving forward, but hashes are great value for looking back, especially say, have I ever seen this hash before? Those kinds of things. So obviously you want it to be scalable across the network. I believe you can make NetFlow definitely is scalable across network. I believe you can make Bro something that's scalable across the network, but some of the other technologies, it'll start to get a little bit more difficult. And then ease of storage. Obviously, full PCAP is going to be your biggest enemy when it comes to disk storage. So kind of going into Bro itself. As I mentioned, it's over 20 years old. It's doing all these great things, right? It's understanding all these protocols that, that you might not even know are existing on your network. And then there's all these frameworks that actually build and make up Bro. Bro's also kind of, there's a script land Bro, and then it's kind of built off of these events and hooking into these events. And then that's how it generates its logs. So built on the actual, the frameworks that Bro talks about, there's several things going on. So there's a file analysis framework. We saw that a little bit in the files log. We saw if it sees a file, and you actually attach, it's called a file analyzer you attach to, and you tell Bro, you can be selective. You can say, just attach to stuff that you see that's a Windows executable, or PDFs or Word docs or whatever. You don't have to attach to all the file types within Bro. You can be selective there. Or you could say, if you see a file, attach that analyzer and do all these things, hash it, or do this. You can actually extract files too with that files framework. Geolocation is kind of self-explanatory. You can get geolocation on. Yeah, I'm not advocating whether or not these are good things or they work very well, but you can get geolocation information on publicly addressable IP addresses. The info framework is pretty cool. Something I learned about last year. Bro has this capability to actually take data that's not network generated or PCAP data and input it in. So I think the example that was used at BroCon last year was there was an SSH server, and they wanted visibility into the SSH server over the network. They couldn't see much information because it was encrypted, but they had the logs from that SSH server that they were then taking and then feeding back into Bro. And then with the data that, say brute force SSH activity, you can then take the log information and feed it back into Bro, and then maybe the IP addresses that is involved in the brute forcing that's coming from the logs are being fed into Bro, and then with Bro having that in, you can actually pivot around and say, what other information or what other activity on the network is that IP address doing? So I thought that was really cool, having that capability. The Intel framework, and if you haven't heard of this, this is where you basically take data, I'll call it. I don't really call it Intel because it's just data, but like IP addresses or domains or email addresses, and you put it into this digestible framework or format that Bro understands, and then you can send it in, and Bro will then do things off of that. It might write to the notice log or send it an email or whatever if it sees activity from that intel that you're feeding. And most of that stuff is meant to be automated. It's not meant to be something that you manually have to chug through. Logging framework is kind of self-explanatory. It's Bro's ability, writing logs. The notice framework, I mentioned that a little bit. That really is if you want to do things like you want to set up an alert, but you don't want that alert to go to an email address, you can actually set it to go to a notice log. So you say, if this event happens, if this happens or XYZ happens, then send it to the notice log, and then maybe just you want to send the notice log to your SIM. Because you have all these interesting things. They might not be evil, but there are a bunch of interesting things that you've decided to attach to the notice log and just send that notice log, or maybe you just want to look at that notice log. The signature framework is kind of what I think what the developers were trying to say. If you have these traditional snort rules and they're looking for this pattern recognition, where you can use the signature framework to define these patterns, and they kind of act as if what a snort rule would act for those content type indicators. And I'm not a victim of counterfeiting, I promise you. And then there's the summary framework. Summary framework, there's a lot of things you can do statistically with the summary framework. A lot of cool things going on. I implore, just go to the bro.org site or look at some examples of how some folks are doing some stats and things that try to do, get analytics on the actual network, the data that's on their network. So Bro out of the box. Like I said, I mentioned if it sees a connection and knows that logs that connection, it's going to create this unique connection ID. And then also creates these unique file IDs as well. And then there's all that metadata in between that is used. And in particular, this is that SMTP example again. One thing with Bro, at least it was a challenge for me, traditionally grabbing PCAPs or looking at network data, I was always grabbing it with Wireshark or Tshark or TCP dump, and I just got in my mind and my brain just got accustomed to looking at this traffic information as client server or source and destination IP, communication. And so I got used to looking at, if I see a GET request and I got to go look for my response or what that response code was, and I'm going back and forth, and I was used to just going back and forth between client, server, server, client, or source, destination, source, destination, source, destination. When I first started looking at Bro, I just see everything on one side and then one IP address on one side and one IP address on the other. And I was like, at first I'm like, are we not seeing the full traffic? Are we just seeing half of the leg? Are we just seeing outbound traffic and not inbound traffic? Because that's happened before. And I just didn't really understand what was going on. What Bro does is it calls this originator and responder. So not really client, server, or source destination. It's what system originated the connection? What system responded to that originating request, right? So when you kind of like look at it from that perspective, you're like, oh, okay, I understand. But it was one of those hurdles that I had to face. I was looking at that and didn't really quite understand exactly what was going on there. Also, like I mentioned, it's very application specific, application aware. If it sees that application and knows that application, it's going to log a log for that. There's going to be stuff like, I know a lot of people worked with folks that says, oh, we're blind to SSL. We have this SSL traffic and we can't see anything. Well, if you look at your SSL log in Bro, you can see a lot of information. So a lot of the SSL vulnerabilities that have been coming out the last 2014 and on, we've been hearing a lot of different things, right? There's these weak SSL TLS protocols. There's these weak crypto algorithms that are being used. So when somebody in your organization says, well, we don't use SSL 3.0, you could just quickly go and look at your SSL log and say, oh, yes, we do, and here's the 15,000 clients that are doing SSL 3.0 right now on our network. And, oh, yes, we don't use those weak cryptos because we push a GPO and we disable all those weak crypto algorithms, and you say, oh, contraire, here's the SSL log, and here's all the clients that are actually using those weak crypto algorithms, because Bro's seeing that connection, and it logs it, and it's logging what's being negotiated, and it's logging the actual the crypto that's being used and the level of TLS that's being used, or SSL. The other thing I wanted to mention about SSL too is, I think it's TLS 1.0 or 1.1, I can't remember which RFC it was, but essentially per RFC, if you're using those protocols, the client has to specify that, that resource indicator, that host name, resource indicator, whatnot. But basically, if it's doing a connection over SSL or TLS to a server, it has to specify the fully qualified domain name of that system that it's talking to. So that's really interesting. Bro knows that, and Bro logs it. So you can actually go look and say, okay, here's all my clients that are doing SSL or TLS, and here's the servers, the actual host names that they're actually talking to. And it's putting that all together in one nice log. Also certificates, it's seeing the certificates that are coming down, so if you want to pivot off of that, there's definitely a lot of resources that are going on there, and Bro's recording those. If you attach the file analyzer and say, go ahead and hash those certificates as well, you can get information off of that. And then I also like to mention that you go and look in your Bro logs, and all of a sudden you see an IRC log, or you see a SOX proxy log, and you're like, okay, what is that? So it's logging the things it knows about, and it doesn't matter what port it's over. If it sees HTTP traffic and it's over port 8080 or 8181, it doesn't really matter. It says, yeah, you're HTTP, and you're going in the HTTP log. Same thing for any of the other protocols that Bro knows about. So some tips and tricks if you want to get started with Bro. I think the last dash capital S was invented for Bro. I say that as a joke, but basically if you start, like if you're just at the command line, you actually just cat out the logs and pipe in the grep, and then you just get this blob of stuff and you're like, what the heck's going on? If you do a dash capital S, it actually doesn't wrap the line and allows you to scroll back and forth. Really cool and interesting if you're at the command line. CF utility, lightweight Unix utility to be able to translate. I don't know, I forgot to mention earlier, but if you saw that first value in the Bro log was actually an epic timestamp. So if you're like me, epic timestamps don't really mean much at face value unless you can read those. That'd be a really cool skill to have, but I don't have it. So, so you can use utilities to kind of translate the epic time into human readable time. There's this concept of redefable or redefinable variables in the script land that Bro operates in, and you can actually use these at the command line as well. So these global variables that you're defining in your scripts, you basically tag them as redefinable variables, and then you can, so one example I like to use is I have a IR script that's based off of, it takes in, it looks for SMTP traffic, And if the variable matches my email domain, it pulls the SMTP message out of the PCAP. And then it pulls the attachments out of the PCAP as well. But if you put like @gmail.com and you have a lot of PCAPs, then that's probably going to be a bad example to use. But you can redefine that on the command line and say, I want any email from evil.com, and I want it to look through this hour worth of PCAPs and just pull that out. It's very powerful to do that. As I mentioned, you can run Bro on saved PCAPs. So you don't have to run it live on the wire. If you use the -r command, you could just pass in some PCAPs and run it that way. And then if you're writing custom scripts, I highly suggest you use this dump-events.bro script. It's kind of hidden in this Bro directory hierarchical structure, but essentially, and there is a caveat too. If you look at that script, it warns you, don't run this live. Because basically it's going to put out, standard out, everything that Bro's seeing. So like I said, Bro logs a lot of things, but there's a lot of stuff, especially in a protocol like HTTP, that it's not gonna log. So if there's some custom header that Bro is actually, so Bro's logging like user agents and refers and all those common strings, but if there's some custom header in there that you not necessarily know about, it's going to see it in the dump events log, but you're not necessarily going to see that written out into the Bro log. So there's a lot of things that the Bro folks do in script land that they actually have regular expressions to kind of say, I want to take this regular expression and write it only if it matches this regex, and you lose some information sometimes. So I highly suggest if you're writing scripts to use this as a debugging tool to see exactly what Bro knows about and sees. Because you can enrich Bro's data by writing your own scripts and then appending that data to the log. And Bro scripting. So if you're interested in Bro scripting, there's this cheat sheet. It was written a long time ago. It hasn't been updated. So some of the commands, they call them BIFs, which is any reference to Back to the Future for me is a win. And so these built-in functions, and they're really great. There's a lot of powerful built-in functions there. Some of them are deprecated, so you'll see that when you try to use those within Bro. But this GitHub cheat sheet right there will show you all that. It also shows you the syntax that Bro uses in script land. And then the 2011 Bro workshop, they actually have a primer where you can actually go through. They start with a hello world, and I think they call it a Brolo world or something like that. But you can actually go through and you actually kind of learn the concept. One thing I thought was interesting is the data types. There's data types that Bro sees and calls, like an IP address is a data type. A port is a data type. So that's kind of interesting from a programmer perspective, that you have these things, these network objects that are now data types that I can use in my scripts. And just really the summary of things is that context is our friend and time is our enemy. One thing I didn't mention, and I wanted to mention with that kill chain analysis, was that kill chain paper was written to do a lot of things, campaign analysis and adversary tracking and things like that. And from my example was just from those delivery, exploit, installation, and command and control phases, that have that good understanding of what you're identifying. But if you're stopping something at that delivery phase and you're successful at stopping it, don't just wipe your hand and say I'm done. In their paper, they actually talk about a full synthesis of an attack. So run that synthesis through, synthesize that attack, just like I did with this ransomware example, and say what would your tools have said if that attack successfully got through the delivery phase. Would you have detected the installation or the exploitation? Would you have detected the command and control? And then you could take that data, enrich it back, and then feed it back into your detection mechanism. So other than that, I think I'm pretty much done. That's it.